Haptics Club podcast. I'm Ashley from Titan Haptics. I'm joined by the Haptics crew. We've got Mandy from Unity, Brian from Sense Club, and Eric from Razer. The Haptics Club is a team of people that have a passion for haptics. Our goal is to raise awareness of the amazing tech and people in the haptic space and foster interesting discussions around it. Today, we have a very special guest, Shan-Yuan Teng, from a PhD candidate at computer science at the University of Chicago. He's advised by Professor, mad scientist Pedro Lopes, as I call him, personally. You've probably seen Shan-Yuan's projects in Engadget, PC Gamer, and IEEE Spectrum. Super excited to talk about them. Before we dive in, of course, be sure to visit thehapticsclub.com and check out our latest blog posts featuring articles from your favorite hapticians and take a peek at our upcoming guests. And of course, you can pick up some sweet, sweet swag, like a Haptics Club mug, a shirt. It's tank top season almost, so you can pick up a Haptics Club tank top at thehapticsclub.com/shop. But that's enough. Let's jump right into it. Let's dive right on in. We are so excited to have you here. Thank you so much for joining us.
Thank you so much for inviting me.
Yeah. And to get started, I wanted to ask you to give us a little brief introduction about yourself.
Yeah, so I'm currently a fifth year, already a PhD candidate now, and I work on many haptic devices. So I created custom haptic devices, usually on the hand, to provide the sense of touch and sense of forces. And I usually create this as kind of a research prototype, as a proof of concepts, and trying to illustrate the idea of how haptic devices can be better integrated into our daily life.
I love that. So what was the initial spark, I would say, that got you interested into haptics and even computer science in general?
Yeah, so my undergrad was electrical engineering, where at that time I was very interested in actually just programming on the software part. So I work a long time on actually natural language processing, as I very intrigued by the coding part. After a while, I feel like I don't really want to stare at the screen for very long. So that I switched my interest into some robotics, and at that time I got into got to know the idea of human-computer interaction. And then I joined the lab doing that, and somehow I just started doing haptics.
How long has been this journey for you since the beginning? That transition from robotics to NLP to programming and then haptics?
Yeah, I explored these topics during my third year in undergrad, and I joined the HCI lab in National Taiwan University, and I did a master there and starting to get into tangible interactions and haptics and VR at that time. And then gradually I kind of focused more on the hardware side, the technical side of haptics, mostly used in VR at that time.
I love that. And we have Eric joining us live right now. Hello,
Hi.
Eric. Amazing.
Hi.
Welcome from my bedroom. How are you doing, guys?
Doing amazing. And so, Shan-Yuan, let me ask you a second question. Can you tell us about your current research focus and any projects that you're particularly passionate about?
Yes, so my recent focus is really about how do we integrate the haptics into our life. And I know that this idea seems very broad. But I think the truth is that most of the haptic devices fail to do so. And when we look back into the history, we will see that what happened when we have computing devices evolving. And each time, haptics seems to be lag behind or even sacrificed. So maybe let me give you an example. When we move from paperwork to PC, we lost all the feelings of paper and pens, and then we only have mouse and keyboards. And when we move from PC to mobile phone, in terms of commercial devices that is very popular, we kind of also lose the tactile sensation of all these from the keyboard itself. Now we only have a piece of flat glass panel. And now we're thinking moving from the mobile devices to mobile VR devices. Now we even can only use maybe just 2 sticks of controllers. And we still have well, not having all the keys on the keyboards, but only 2 vibration motors on each controllers. Yeah, and so I'm just keep thinking about how haptics have been like losing its ground when we move these devices into a more mobile form factor.
So it's
and like if it's
the transition to mobility has kind of reduced the opportunity for better haptics, is what you're saying.
Yes, that's what I'm really observing when we see like these new exciting products where they have very nice visuals, but we usually like they sacrifice a lot on haptics. And so my PhD research is trying to figure out what's the problem that comes to integrate these haptics into these products. And it might be because of they have these very big actuators, and it might be because of they have very large power consumption, and they have been like other problem like how these can sometimes interfere with our real world. Yeah, so I've done a lot of physical prototypes, trying to try out different ideas that might maybe partially or like solve this in a alternative way, so that we don't have to like sacrifice haptics as a whole. So we might have some space that we can trade off and then design for.
I love that. And so right now we're going to move to the second part of our interview, which we call the area of expertise. So I'm going to pass it to Ashley for the next question.
Awesome. Super excited to dive deeper into that because you've said a lot of really kind of bold things so far. And so we're going to mix those with understanding more about your projects. But I think I wanted to start with your website mentions that you aim to advance a next generation of haptic interfaces. So be able to create the sense of touch forces that exhibit properties that we can use to expect. Oh, wait, sorry, I misunderstanding this, to exhibit properties that became used to expecting from our mobile phones. So exactly as you were saying. So you're saying, this idea that we used to expect this idea from our mobile phones, and we're looking to create this new kind of like advanced generation. Like, what is this vision as you see it playing out? Because we've got this existing ecosystem of products on the market today. You've got this idea from like an academic area of like being able to experiment with this. What is this like? How do you see this tangibly rolling out from the things that you're working on to, really changing the state of how people can interact with devices in this vision of yours? And sorry for mixing up the blurb from your website, which was so beautifully posted.
Yeah, no worries. Yeah, so I'm trying to think about how to put this in a good way. So I'm thinking about how we wanted to use this. We want to access information in more on like a less restricted way. So that's why we developed these products. And while I'm thinking maybe haptics should also behave the same. Well, because what I want to say is that there are lots of opportunities for haptics in the future in this mobile but also immersive environment. But however, when we aim for the immersive, the haptic side is often like very easily sacrificed because of numerous technical difficulties and also their design choices. So my research is trying to perhaps explore the alternatives of designing haptic devices so that they can also play a role in the future. Yeah, I can also dive into more details about the technical prototypes just to illustrate these possibilities.
Thanks, Sean, for sharing. I am interested to hear from your opinion that you mentioned that haptics get sacrificed, and you just listed in a short way number of things. Can you dive deeper? Why do you think haptics get sacrificed in the different use cases?
Right, that's a core of my research. So maybe I'll get into the hands first. So we see like while we move from mobile VR to like now very popular Vision Pro and the Quest 3, where you can see through the headset to interact with the real world. And so here we see a very strong conflict here with a lot of traditional haptic devices. For example, like haptic gloves. And they're not really suitable for this new coming headsets like used in augmented reality, because when your hands are all covered, then it's very difficult for people to interact with the real world anymore, because you still need to or like want to feel the textures of your clothing. Besides, you might want to feel the texture of the virtual clothing, but this is the real world that we live in. So by having the users to sacrifice their original haptic sensation to the real world in order to like exchange the feeling of virtual world, I think that is a very, very high cost and making the haptic devices not suitable for integrating into the devices.
So the transition to mixed reality from virtual reality is creating this challenge, is my understanding, because there was no problem with gloves in VR because you don't really need to use the real world. But once you have augmented or mixed reality, you need to have both. And now the gloves are amazing for the virtual part, but the physical part now is lacking the real sensation. Got it.
Yeah, totally. So some of my projects has been focusing on proposing alternatives to haptic gloves. And one of these is creating a device that is not a glove, but like a nail. So this device only sits on the nail, but it does not cover like your finger pad. So while current proof of concept is still kind of big, but I envision you will wear all these little things on your nails, and they can unfold a cover onto your finger pad to tap your finger pad to create a sense of touch. And when it's over, it should unfold itself back to the nail so that it doesn't encumber your finger pads. So you can think of it as a shape-changing nail. So it only like provides pressure, temperature, or like other sensation on your finger pad when needed. And when you leave it, it just tucks away.
I mean, I think I filed a patent on that like 5 years or something like that, 5 years ago. No, it makes sense. I mean, when we were doing some VR stuff like 2016, whatever, it does makes a lot of sense. We actually tried to implement it. We had a VR touch, which was this flaps was connected with filling up with the servo motor and then goes down. The problem that we found actually in reality is that we did build out the prototype is that you would be surprised how anything that is above your fingernails, even if it is, few millimeter thick, will encumber your movement. And you will start to smash it around and you don't even realize how precise you are your finger. If you grab wonderful. Grab a cup here. And you would like to do this motion. And that's dependent. It's really dependent on how thick it is. If you add like 5 millimeter, you will not be able to do it. So you will be encumbered. So what we found as a challenge is that ergonomically wise, even just adding a few millimeter on the tips, not here, because if you put like a big ring, you don't care it's around here, right? And on the tips, it becomes straight away like a user interface burden if you need to use it all the time. And I'm interested to see how you could solve that challenge with current or future technology, because the best haptics interface should be non-existent. The things that you don't have it, right?
Yeah.
So I'm really interested to understand what's the dimension which is acceptable from ergonomic reason, these type of things.
Yeah, I totally agree with Eric that this idea try to preserve the tactile sensation on the finger pad, it adds more burden on the back of the nail, and it might limit the mobility interacting with in the physical world. And I think, definitely, I think there are more studies that we don't know yet, like how much should have the least encumbrance in the real world, and if we have the technology that can minimize, like, for example, my previous approach to replace the thick DC motor with other shape-changing materials that can be even thinner. And I think that is one of the limitation of my current approach, and I'm always curious about what can be improved. And so actually, in terms of this, I also noticed this problem. So the recent research that I actually demoed at Haptic Symposium just a few days ago was a research work focusing on, so now I'm not talking about nail type devices, I'm talking about the skin-like devices. So you might seen a lot of skin-based devices on the finger pad, especially to create a sense of touch. And there have been a lot of research work on especially the technique called electrotactile, using electrodes to pass tiny currents onto your finger pad to create the sense of just a tiny tactile feedback on your fingertip. And because these are just electrodes, so they can be made very thin. So we've seen a lot of these thin devices like in the past in the field that they can maybe have like almost as thin as a few microns. Yeah, so we were very interested in perhaps this might really like preserve the haptics that we want in the real world. So yeah, so in the research, in the process of research, I tested it out, but even though it's still very thin, I still feel like I'm feeling through the world like wearing a pair of gloves. And you can feel the tiny haptic features, but it's still a bit far from the feeling of using a bare finger. So my research is trying to see if there's a way that we can actually improve that. And I found a very simple but naive approach, but actually very effective. That is just by adding holes to these films, like physical holes. And actually, this partial reveal of these finger pad ridges can a lot enhance or preserve our haptic sensation when we touch real-world objects. So I demoed this at Haptics, where I show like a mixed reality scenario. You would interact with physical props like the fabrics, but also interact with virtual objects. So in this case, we want the users to feel better on the different fabrics, because you really want to feel like the furry feeling or the distress from the fabrics, and not really like feeling through a film. So we found that those little holes, even though not big, the hole that I'm saying is like a diameter of like 2 millimeters. So it's like kind of the small. And
it was larger enough for
but it's shown
the
that
person to be
this
able
can
to
be actually largely enhance the sensation. Yeah. Yeah. So that's what we found in our study.
I like that approach quite a lot, because I saw a few prototypes, I don't think a couple of years back, 1 year ago, where it was using the inverse principle, and it was an interactable surface, it was clickable, and to allow to make it end, but you wanted to have a local haptics experience. So they were making a hole on the interactable surface, and output few pins, which were basically the inverse matrix of what you're saying, so that you could have local haptics at a specific place without having this full system working, the full system vibrating, and basically was a waveguide that was bringing it in the local place. And the sensation, and I checked your paper, the images, actually the distance between the pin was basically the same as the distance that you found. And it was really nice, because you could have like localized vibrotactile sensation through this waveguide without losing the ability to interact with the solid surface and non-vibrating surface. So I liked it quite a lot, because you had this basically flat surface, and it was a bit indented output. It's basically the same thickness that you could transmit the vibration to your finger. However, you could still feel the rest of the surface. And when you, for example, would click and was a clickable surface, you would indent your skin locally, but you could still feel the system clicking. So you have these two these two sensations that could get mixed in real time. So
as you
I've done a struggle to agree that
no, as you both explained, the way I saw it was a little ladybug, and then the red section is your real screen, and the black dots are the haptics part.
Yeah, exactly. Basically, that's exactly it. And I would love it not to be electroductive because the electrocycle sucks. Something else, do something else. But yeah, I think it's a great idea. Congrats.
Yeah, I would totally love to try the device. Yeah, so we're thinking about the kind of a real augmented reality in terms of haptics. How do we really mix these things very well? And yeah, so that's one of the things we're just like I think it's just a initial point to explore this possibility. And I think the next step would be to understand, like, now if we can really augment like physical objects like better, then what can we do with these haptics? Can we like modulate the texture of physical objects by using this, or can we provide better haptic guidance using, for example, like a screwdriver or more fixed complicated tools? Now we can provide information directly on the finger pad rather than perhaps previously you would present those information on the wristband or like other places that are just less cumbersome.
Sorry, question here. Did you evaluate the difference in user experience actually to the related task, clicking? Because at the end of the day, we are doing, brutal, my view of haptics. We can claim what you want to say, we are rendering the digital world and physical world. The reality is that we are doing clicks and we are doing sliders and we are doing these things like 95% of the time, right? So probably that's what people care on grabbing stuff. So did you evaluate the difference in user experience when you would have, let's say, a wall and you're clicking the wall and you're making your virtual click with your finger pad, and the same virtual click with a little vibrotactile actuator on the ring, or DASB thingy, wristband, whatever, to understand if there is an impact of the distance of the sensation? Because if you have a vibration here and your Pacinian covers all the hand and you're clicking over there is some kind of transfer, right? So the question is, how much is it required to have a local sensation versus how much you can get it away from the impact point? And is there a measurable influence of the user experience? So you can understand what are the trade-offs that you're taking by putting things on the finger pad.
Yes, I totally agree. We only did a very initial study, but like the study involving like tweaking these parameters, I think this is actually pretty needed in this field to really understand. We have not done that yet, but we really wanted to do that study. So the study that we actually did as an initial exploration is we did compare vibration on the nail and compare that with clicking feeling on the finger pad. We did not evaluate this in a performance study, but we asked about how similar does this study compare to a real button, and people rated like having feedback on the finger pad is much similar to a physical button. And that's something that we found, like this location matters if you are trying really to render some conventional widgets or like surfaces. But in terms of performances, we have not done studies on this. So we were also very interested in, if you're just doing typing, like would it really matter, like where you feel the haptic sensations? But in terms of realism, we did find a difference here.
Just a feedback from a business side of things is that it's really harder to sell realism somehow. So it's in general, it's good to have the two views. One is the realism side of things, the other is the utilitaristic kind of things. So that's how useful it is, and that would help to understand if if it's good to take it and make a product out of that, or it's still some iteration on understanding if what could or could not be done. Sorry, asking you.
That's exciting. I think, yeah, love to, if you ever do that study, obviously you've got a captive audience here for that. But I think before we dive too deeply into it, I also wanted to get your opinion on, you were just at the IEEE symposium you mentioned, it sounds like you had a badass demo. What other demo to you stood out that was like innovative that you haven't seen before, or was just like the most enchanting user experience?
Yeah, so I've tried many demos in the symposium, and I feel like some of the most impressive demos were the use of illusion in haptics and utilize this illusion in more of a practical way, I would say. So, for example, one of the the demos that everyone really enjoyed was about thermal referral. This idea of you might feel thermal sensation at a different location if that location is presented with a vibration. So I tried the device, which is like pretty magical, where you have a thermal stimuli on your forearm, but you have a vibration motor on your upper arm. And when the thermal feedback is activated, so it heats up, and the vibration motor is vibrating at the same time.
So wait, not only the upper arm felt hot when it was just vibration, but it also canceled out
hot. But you will feel your upper arm like feeling hot.
So that's why you call it the transfer.
Yes. So the forearm thermal sensation is being masked out by the vibration on the upper arm. Yeah, they're calling this referral, and that's a demo from the UT Dallas. Jin Yong Kim's demo. That was very impressive.
That's super cool. Did they have like an experience with it? Were you like doing something particular, or were they just kind of like showed the demo working on its own? I'm curious for like someone listening who's like, what the heck would you use that for? Yeah.
Right. So I guess that is a very good news for people engineering haptic devices, because thermal feedback is very hard. So you probably don't want to put thermal like elements on all your body, but now you can probably only put a few, and then you can kind of move that thermal feedback away. So I think they've also shown like a bodysuit and other form factor,
working
like with a minimal
wristband with thermal
modules that can render a full body
4 years ago,
like
and
a thermal sensation.
At the time, it was really hard to convey the same feeling with the same intensity in different parts of the body. Obviously, we all saw the along-this. And so, for example, heating up about just 10 degrees on the fingertip made the person feel as if he was heating up to 30 degrees. And same on the opposite side, you didn't need a lot of cold to feel like very harsh cold. And we discovered that the transition between a temperature and another one was what make us feel the temperature and not the actual temperature of the element. So making a change from 10 to 12 make you feel hot. It's not the fact that it's 10 degrees, which is interesting. And now hearing what you just said, I'm thinking that can be so useful for also parts of the body that are maybe less good at receiving the perception of temperature, but they are very good with vibrotactile and being able to actually convey temperature in areas that before we could never really do as precisely, or it was too costly or cumbersome even, because those are not the same shape of devices. So it's very interesting. And also for those that don't know, IEEE was just 2 days ago. You just literally came back. So those are almost scoops. Thank you.
Yes. Yeah, so I think there's really a lot of this illusion like we can really use and in a very practical way. And actually, there's another demo where I really like. It is also utilizing the sense of illusion that we might sometimes not care about the precision of this feeling, but we just need some kind of feeling. So the demo that I tried by Soma Kato from Kajimoto's lab, they present a wearable device on the fingertip where the device is just a rotating disc. So it's like a very tiny disc rotating on your finger pad. So it is always rotating in the same direction. So when you're doing nothing, this is like static. But when you are going to slide your finger across a virtual surface, this stick starts rotating according to the speed of your finger. But no matter like how you slide, the disc always rotates in the same direction. However, you feel very realistic. It doesn't really matter like what is being rotated
So it's
underneath
like
the finger pad,
tracing
but it's
sensation
just
almost.
the sensation of slipping. Like
Love it.
you feel really realistic. You couldn't really distinguish if it's slipping in a like right way or yes, it's like a tracing sensation.
I mean, I love all of this because it goes back. I mean, I'd like to work a little with Vincent, and when he was teaching haptics, we were always saying, look, haptics is touch is an infinite dimension problem, as it cannot be solved because it's a soft skin, soft matter against something else, and you have to understand what the heck is going on, right? And you just don't have the computational power in your brain to solve that. So you do a ton of assumption, and he did a lot of work around that, right? And specifically on the speed, I think he found that actually with 3 or 4 different vibrational frequency, you can do every type of texture. But on the flip side, it also worked like, oh, the direction of vibration doesn't matter. The frequency really doesn't matter. A little bit, the intensity does matter. But I think
I have one last question about the symposium. I don't know if you had a chance to try this one. It was from you et al. It's a sharing grasping experience in VR. So basically, one user was touching a sphere, let's say in virtual reality, and the other user just had their hand floating with the same device, and they will share the grasping experience between the two. So like telekinesis, but also in a sense, like through sensation of haptics, which the ones looks a bit magical to me as well. Like I love illusions, and I think there is many.
I know that
it's
demo,
not just for the fun.
I didn't have a chance to try that.
There's real use cases that I think can be derived from that for people with disabilities, or for controlling robots from a distance, or going into very difficult locations because of nuclear problems or hotness or cold, and having still the sensation of presence through that.
Yeah, I really agree that haptics has this power of transmitting knowledge through another way that people can really feel and really experience rather than just like understand by words and by pictures. Yeah. So
I'm curious, like in terms of designing haptics, creating an experience, like the kind of interesting thing about the haptics world is you have to design it around people, and people are so different. I'm kind of curious in your opinion how like cultural or societal factors influence this creation of whether it's like experiences, devices you're making. How does that factor in?
Yeah, I think that's a very big question, and well. Yeah, to be honest, in my research, I didn't really focus on this part, but more on the technical design and more on the object, like the psychophysics studies about this. But I do agree that the idea of haptics might be differ like a lot. Well, I guess a very simple example is that when we present the sensations, it's often like some people feel really good about a certain sensation, but some other people might feel annoying. And this is especially very prominent if you go to like electrotactile devices or electrical muscle stimulation, where you put like electricity into the body, and their response are very different. So this is a very hard problem. That how do we design haptics for the individuals? And I think I also see a very nice approach that is like kind of demonstrated in IEEE haptics this time, is that they're showing it's almost like you're going into an optical prescription place. So before you try out the haptic devices, you're going to fit your fingers into different holders and find out the most suitable size for the devices. And besides that, they also test different resolution of their haptic devices. So they have this kind of simulated textures where you can wear different devices with different sizes of little things. They are passive. these things and trying to feel the textures around to see what kind of pixel sizes will be suitable for that individual persons. And after that, they're trying to develop a device that can render texture sensations using those pixels. So I'm just it's still very simple right now, but I'm really intrigued into this idea of really having a customized approach to design a haptic device that works best for that person.
Love that, especially the use of the optical store example. It's also like going into a retail store, and it's just like, what size, what texture do you like? Everyone kind of has a preference, so that's a really great example. I appreciate that. I'm curious, as a PhD candidate, you've seen so many projects, you've described some really fun ones so far. For someone that's kind of like curious about the area of haptics or is interested in maybe pursuing it further, like what kind of advice would you give them on, things that you learned along the way? You've probably hit some challenges. Like, what would you tell these like future students so we can get more people, future hapticians in the field?
Yeah, I think it's very also very hard question because haptic is so big. Like you can go in from any directions. Like for me, I entered haptics because I was intrigued by lots of very cool mechanical devices like inflatable. So that's how I entered haptic, because I was very interested in the sensation or like how these devices can do. So I think maybe building is very important because, I build haptic devices. So I feel like trying out devices or like replicate like existing devices and to see how they work. Well, they often doesn't work as like that well. Well, most devices don't work that well. For now. So I feel like having the experiences of buildings might actually strengthen like your understanding of haptic devices. And of course, I think trying a lot of things and maybe, I don't know, can really like have an imagination of how future can be and not restricted to the prototypes or the devices that we have today. It's also very important.
Yeah,
because usually these haptic devices seems
so optimism is also a soft skill that you need to nurture.
As a researcher, I'm always optimistic. I think there's a way to incorporate this into a future product. I think so. And curiosity, I think curiosity is very important. Yeah, it's like, because I think for me, I'm always very curious about what kind of sensations that you can feel through these devices. And working in haptics, there's a very nice feedback that you will have every time you explore something. It's the actual feeling. So you get the actual feeling every time, and it's rare that you can have a research that you can confirm by just feeling it. So haptic is one of those that you can just feel it and you know that this is good or not.
We are actually
I feel like that is like a constant motivation for me that keeps me going.
Haptics. And my first question for you would be, and we kind of touched on that earlier, but what do you think will be the role of haptics and what role it will play in emerging tech fields such as VR, AR, or wearable technology? And you can think 5-10 years from now, not necessarily short term. We only have huge question here.
Yeah, this is a huge question. And nice. Yeah. So I think I'm very biased. Like I really hope that haptics can play a role. And I also think that maybe many people also have this hope too, because we really enjoy touching physical objects. Like most of people prefer typing on the physical keyboard than on the fully virtual keyboard, and also being able to feel objects is also like something that I observe, like the wonder of being able to feel something is like really something that I observe during every demos that I put it out. So I feel like in the future, haptic can be beneficial in a lot of different ways. Like in very basic, this can make devices easier to use so that we're not just touching mid-air objects with no feelings. And this can really, if things are easier to use, then we can use them in a lot of different scenarios. It's not only limited in like very well, not very limited in, for example, like gaming, but this can really be out there, like in classrooms or like in the wild. Like I'm really wanted to see haptics that will play out in the wild. Like for example, you're going out to camping and you can still like read these instruction manuals, like how to put up a tent and how to like make a fire, and with all information that haptic can provide, and you can learn knowledge like where you are, like using these haptic devices. So that's something that I really want to see. But I think practically there are a lot of things that we wanted to trade off. That's very important to understand like how much haptics will be used for in that scenarios, and how can we bring that haptics there. I think for now we have like very, very strong haptics in like surgical training or like a lot of vehicle trainings, and we have super weak haptics like with just vibrations, and we're thinking what is something that in between these, and they can be like brought to where people are really working and living. I love your answer,
because you actually answered my second question at the same time.
Like you just because I was about to ask what would be some
day-to-day life example of where haptic could be impactful.
Like
and you said something about the camping, like which makes me realize something very tangible, is that obviously when you get into VR, mixed reality, especially now with spatial computing from Apple, like people are starting to be experiencing those new type of interfaces. And for many people, it's their first time. For a lot of us, it's not their first time. But there's something kind of almost refreshing to see, is that people are naturally going a bit of wonder whenever they have hand interaction, because for the first time, it's not a controller being an interface between you and the interaction, but your own hands. And obviously, the first reaction of people is, oh, but now it's a little bit more clunky or a bit harder because it's not really natural. I mean, the gesture is natural, but the feeling is missing something. And you want to grasp at an object and feel it. But the fact that you can point and click was the most natural aspect of the Vision Pro, for example. And when you go on the Quest 3 from Meta, on the haptics level, sometimes the point and click gesture was already invented, and being able to just have the haptics from your own finger tapping each other is very simple, but so clever. And what we're missing now is the other type of interaction you can have with your hands. And when it comes to mixed reality, you said something about learning. I think it's very important that we put an emphasis on that, is that obviously your body understands every single one of the inputs coming from outside, and being able to learn a gesture or a movement or something new by feeling, or getting just the feedback to confirm a movement or to confirm that you did something right. That's literally how we are training pilots, how we are training surgeons. So in the day-to-day life, there's many use cases that can derive from that. And I believe that the technologies that you're exploring, the ideas that you're exploring are getting into that spectrum in between those two. So I wanted to ask you, is there any other use case of a day-to-day life that you think haptics could impact in the future?
Yeah, I think it's really up to how much haptics that we can have. For example, you can, with the perhaps very basic haptic, providing confirmation is already very useful for lots of tasks like typing, or using like a lot of productivity things in the future, or even like 3D like drawing or design of a architect, or like or like just showing a lot of physics models when you're learning in classrooms. I think very basic haptics can be is already very useful for lots of productivity tasks. But with more features like rendering textures, and that might like move haptics into another place where, for example, like retail, so like selling clothes, and you might want to like feel the textures before you buy the clothes. Or if you're a designer, you wanted to feel the materials before you actually manufacturing them. And so I think that is maybe a next step where you can feel with textures,
Haptics.
with softness and material properties. And yeah, I think that is very powerful because nowadays we can share images. What if we can also share the textures, the shape of an object? We can capture something, and then we see this.
We need a tactile Instagram.
Stuffed animal that I really like here, and do you like that? And can I take a picture
Someone is
of
working
this?
on this
and
right now. I don't know.
You can feel at the remote place, and if you like that, then we can. I can send it to you, something like that. So I think that, yeah.
Yes.
I mean, that's a good question, but the question is, who decides which haptics goes where?
And there's many also question around the social interaction.
That's actually
of
the big
it
question.
And,
it's not about the
personal safety, privacy, and everything that goes with that. Because it's not just about touching something, but also as you touch something, you are being touched.
Probably, I think, the biggest challenge.
We remember the first few days of VR in social experiences where people were just feeling weird having someone in their space without the tapping part. So there's a lot of not just concern, but like things to take into account when you design those experiences to make sure people feel safe from A to Z. And I agree with Eric. It's probably not a technological problem, but more of a ownership, safety, etc. Yeah. Yeah. Where will you be
definitely,
in 10
I agree.
years?
Haptic can have a very strong impact on the person.
Yes.
Like,
what do you think would you be working on, or
behavior
maybe
even.
you won't be in haptics anymore? Who knows?
We need to be very careful when we design interactions. Where will I be? Yeah. For now, I'm still very interested in haptics, so I really hope that I can continue haptic research, perhaps in the academia environments. And I like it because, well, I like to explore alternative solutions. I'm not really satisfied by what I am offered, so I really want to see if there's any other approaches, even though they might not seem practical now. But I think I really enjoy, something I really enjoy.
That's a great answer.
I hope hopefully I can keep working on haptics, and perhaps until everyone has been wearing haptic device for their daily life, then I think I will switch to another topics then.
Very cool. And where can people find you if they want to learn more about you, what you're working on, what your lab is up to?
Yeah, so I have a personal website, Shan-Yuan.info, and you can find all my researches on my website. And besides me, I work in the lab at University of Chicago. So many of our lab mates work on very different like sensations or problems, mostly in terms of haptics and also including other topics. So for example, if you're interested in smell and taste or other electrical or magnetic stimulation, you might want to check out some works in my lab.
Very cool. Doing such cool stuff. But unfortunately, sadly, guys, this is the end of this episode. Really want to thank you, Shan-Yuan, for joining us. For anyone listening, be sure to check out thehapticsclub.com and follow us on LinkedIn, X, all the places you'd expect. And you want an amazing conversation starter yourself? Pick up a Haptics Club shirt, a mug, hat. People will ask, and you can get that at thehapticsclub.com/shop. And of course, catch all of our episodes on where you'd expect as well: YouTube, Spotify, Apple Podcast. That's where you'll find it. And a big thank you to our listeners, to our fans, and our supporters. Thank you so much. And as Dr. Dre and Snoop Dogg say, see you with the next episode.